Friction makes it difficult for us to move things along a surface. It however also makes it possible for us to walk or run without sliding. It helps our cars to stop when we apply the brakes. Welcome to Exquisite. In this class, we will start learning about friction, and some important laws regarding it.
Sensei, I know that friction is a force that opposes motion. Anything else about it?
Yes, friction opposes motion. A lot of people know this, but they usually don't understand it clearly. Let me explain.
Okay.
Friction is such a mischievous personality, that it always acts in a direction that opposes motion. As an example, if I try to move this box to the right-hand side, friction will act to the left-hand side. And if I now turn around and decide to move the box to the left-hand side, friction will now act to the right-hand side.
Oh, that is really mischievous.
Yes, whenever we try move a solid over another, there is always friction acting in the opposite direction in which we want to move the solid.
Okay. Now, does friction only act between solid surfaces?
There is also a similar idea as friction for liquids and gases. It is specifically called viscosity. We will learn about it in subsequent classes, but most of the times when we talk of friction, people understand it to be the force between solid surfaces. To be very emphatic, some people usually refer to it as solid friction.
I see. So we are learning about solid friction in this class.
Yes. The major things to understand about solid friction are embedded in what we refer to as the laws of solid friction. There are a number of them, but we'll talk about the basic four, in this class and in the next class.
Okay.
We already starting talking about the first one, and it says that friction always acts in a direction to oppose motion.
Oh, I get it.
The second says that the frictional force between two surfaces is directly proportional to the normal reaction between them.
I need an explanation to understand this one.
Okay, I think I should first explain to you what the normal reaction is. If we have a box, or any other object on a surface like that, then the normal reaction is the force which they exert on each other, in a direction that is perpendicular to their surface of contact.
Okay.
For the case we have here, it is the weight of the box, or the object.
Oh, I see. The normal reaction is always equal to the weight of the object?
No, not always. The normal reaction is equal to the weight of the object, only if the weight is perpendicular to the surface, like in the case we have now.
Okay, that is if the surface is horizontal.
Yes, but if the surface is inclined, like in this other case, then the weight is no longer perpendicular to the surface. The normal reaction is always perpendicular to the surface. This is why it is called normal, meaning perpendicular, or at right angle.
I see, the weight is always directed vertically downwards. So, for an inclined plane, the normal reaction will not be equal to the weight.
Yes, the normal reaction will rather be equal to a component of the weight that is resolved in the direction perpendicular to the surface. We will talk more about this in a subsequent class, but it is worthy to note that the value of the normal reaction is always less than the weight of the object, for an inclined plane.
Okay.
So, now you know what the normal reaction is. The second law says that the frictional force is directly proportional to the normal reaction.
Okay, other conditions being the same, the frictional force will increase if the normal reaction is increased.
Yes, one way to increase the normal reaction is by adding more load. Then the normal reaction also increases accordingly.
I get it. If I have two similar objects, with one being heavier than the other, the normal reaction is bigger for the heavier one, and so the frictional force will also be greater for that one.
Yes, because of this greater frictional force, you will need more force to move the heavier one than the lighter one.
This law is very clear to me now, thank you for the explanation.
Okay, let's return to the proportionality.
Yes, I know we can usually replace the proportionality sign with an equality sign, and then introduce a constant.
That's right. That constant is called the coefficient of friction. It is a dimensionless quantity because it is a ratio of two forces.
I see. Friction is a force in newtons, and normal reaction is also a force in newtons. The newtons cancel out, and so the coefficient of friction has no units.
Correct, and that's where we end the class for today. We will continue with the other laws of solid friction in the next class. Kindly give us a summary before we go.
Okay, the two laws of solid friction we studied in this class are: 1. The frictional force is always in a direction to oppose motion. 2. The frictional force is directly proportional to the normal reaction. The normal reaction is always perpendicular to the contact surface. It is equal to the weight of the object in a horizontal surface, but less than the weight of the object in an inclined surface. The constant of the proportionality is known as the coefficient of friction. It is a ratio of the frictional force and the normal reaction, and so it has no unit or dimension.
Great. See you in the next